we can now dive into Intro to Python for AI. So here we're going to jump into the scripting language of Python, understand why we're using specifically Python, and understand some of the key concepts of not just Python, but software and programming languages in general. So let's dive into it. Okay, so first of all, why Python, right? I'm sure you guys, whether you're very proficient with programming and software, or if you're completely new, I'm sure you guys are aware that there are many different software options and programming languages available: Python, C, C++, Java, and the list goes on and on, right? So the question is, why do we as a club and a lot of the industry tend to stick with Python, and why do we keep going back to the same one language? Well, first of all, Python's powerful, right? Like brute forcing your way through problems and implementing simple solutions works really well in Python because it doesn't complicate sort of the work that you put into it. And the implementation is very easy. And this is a lot of it's because of its intuitive syntax. And by syntax, we just mean what you actually have to type and what words and phrases mean what. It's fantastic and very intuitive, and it's great for prototyping. This allows you to get very, simple models out very, very quickly. You can test things a lot quicker than you might with other languages, and this is mainly just because everything's sort of built with Python to be done in an intuitive and simple way. There's also extensive libraries. We're going to talk about these libraries a little bit more in the following presentation after this. So these libraries, the ones we'll be looking at will be fantastic for AI, but the libraries are very extensive and they cover sort of a lot of different portions of software in general. You have libraries for deploying web apps, you have libraries for AI, you have libraries for like video tracking. Python, very open-ended in terms of what it can do because of these libraries. And a lot of these libraries are created by the large community that we have around Python. That includes not only ourselves as Western AI members, but also just online. A lot of people are very open with the software, their own personal software that they use Python for. And this is fantastic because, like I mentioned in the previous presentation, that you don't have to build everything from scratch, and it's perfectly fine if you take the code or data or library from somewhere you found online or some sort of resources that you think is reliable. And thanks to this large community of developers that are there for Python, specifically in the field of AI, it makes it really easy sort of to get going with a project a lot quicker than you would have in most other platforms. And then finally, Python is perfect for beginners. A lot of people find coding and software development very challenging and very intimidating to sort of dive into. Python helps make this a lot easier of a process, and it tends to be what most people feel most comfortable with when they first jump into it. I personally, Python was one of the first things I learned, and a lot of this has to do with the syntax. It's very intuitive in comparison to what we see in a lot of other languages. So let's go over just a quick content overview, a little rundown of kind of what we want to look at when it comes to the syntax that we'll see, as well as like the variables, some of the more basic things, just a quick overview for anyone who is very familiar with Python, and just a good introduction for anyone who isn't. Then we'll run into things like functions, Booleans and conditionals, loops and classes. So these are just key aspects of Python that we'll be using. And these are just components that help introduce the language as well as just software structure to you guys as a whole. And they'll come into play when we look into our more complex workshops as we keep going throughout the day. Basically just give you a nice solid understanding so you're not falling behind when it comes to us going into things like functions and classes in further workshops. So let's go through a quick review. So don't freak out. A little piece of code, not too complex. We'll run through it together. So first things we have to do is what's called a variable assignment. So in this first line here, we have chocolate equals 0. What this is doing is we are creating a variable. Just like in math, a variable is just a placeholder for an actual value. So we're saying that this value of chocolate is equal to 0. Some of you might have experience with Java or C++ or these other languages and understand that you usually have to define what your variable type is. And by variable type, I mean what is the data that we're storing. Here we're looking at a number value, so 0, so we're going to call that an integer type. In Java, for example, you would have to specify to the computer that chocolate will be an integer value. Python, luckily, we do not have to introduce that. Python is very friendly, and it automatically assigns that variable type to whatever variable you put in there. So, for example, with chocolate, we could actually have a text value there, and that would be a string value. But in this case, like I said, we have a whole number 0, so therefore we're going to call it an integer value. Some of the variable types you'll encounter are integers, which are whole numbers, floats, which are decimal point numbers, strings, which are pieces of text, characters, which are single characters of text, as well as lists. Lists are just multiple sort of data together in a list. So it's a lot simpler in Python than it is in many other languages, mainly because it auto-assigns everything for you, which is fantastic. And then followed by that, we have a print statement. So this is a function. The print is a built-in function in Python, but it's pretty good to explain how it represents functions as a whole. So basically, you call this function and you put something in the brackets that you want the function to use. In this case, we have the statement you have whatever value chocolate holds, and then this statement chocolate bars. So in this case, we have 0 chocolate bars. So if we ran this print statement right now, it would be you have 0 chocolate bars. And this is basically, there's code that helps display whatever values that we're giving it through. And that code is basically simplified into the print statement. So instead of using that big chunk of code every time that's built into Python, we just use this print function. And that helps us run that code a lot quicker and a lot easier than having this big blurb that prints things to your screen. Then we are creating a new variable. This is a variable we're going to call store. And again, we're not going to define what goes into this variable. Could be a number, could be a piece of text, could be a character. The computer will decide that once it gets that variable. So if you see that this is a unique situation because we're making a variable equal a function rather than making it equal a value. So in this case, we're using an input function. Basically, all this does is this input function will be replaced by whatever value it returns. So in this case, the input function, you give it a piece of text, it will prompt a user with that text and then save whatever the user enters as the value. So if do you want to go to the store and I enter a Y, that's the value in store now. And then we have what's called a conditional statement. So this is an if statement. Basically, it's saying that on the condition that this value store is the same as the value Y, then we will continue through the code. Now is a good time to point out the structure of Python. So if you guys are familiar with other languages, like Java, you usually have to worry about making sure that you have brackets in the right place and semicolons where they need to be. Python doesn't work off the bracket system. So just to clarify for anyone, this if statement, the code that follows inside of it in another language would be encapsulated in a set of brackets. But Python is based off tabs. So as you can see under the if, the next 3 lines are tabbed in, which means they're within that statement. So your tabs and your actual spacing and structure of where your lines are is actually very important in Python, which is different than other languages, where in other languages, you technically could just have everything in a single line and it would run. It would be very ugly, but it would run. So like I said, if this one condition is met, then those next 3 lines will run. Otherwise, it would skip those next 3 lines. Again, we have this print statement, and that print statement will print the updated value of the chocolates once this code runs, and we'll run through this code at the end. So now we're going to jump into loops. So loops are basically just a way to run code over and over and over without having to actually have those code lines continuously repeating. So this is one of the data types that I mentioned. This is a list. So basically a list is just a set of values of a certain data type. So for example, milk is a piece of text, as I'm sure you guys are aware, and that's what we call a string. So in this case, we have milk, dark, white, almond, and orange. So we have 5 pieces of text in this list. So when we run this for loop, it'll let us print every time there's something in this list, and it'll print item. So we're doing a 4 item in Choco list. Choco list is the list with all those chocolate types. So then it'll run the next, any of the tab lines. So in this case, print item. for each value in that list. So it'll print first milk, dark, white, etc., etc. And then we have a secondary type of loop that follows that. So in this case, we are using a while loop. So a while loop is different from a for loop in the sense that a for loop has a condition, like it has a certain number of iterations that it'll run. So if we go back, it'll only run for items in ChocoList. So as long as it iterates through an item in ChocoList, it'll run. Once we get to the end of that, we're out of values to run, so nothing to run. The list is ended, so the loop will end. So back to the while loop. In this case, we have a while. So as long as a condition is considered true and a condition is met, then all the lines that are tabbed in afterwards are within the while loop, and they will continue to run until that condition is broken. So you could have a situation like this where you have a variable, so in this case I, and then your condition is that I stays under 10. So as long as I stays under 10, all of these tab lines underneath will continuously run. So the first is just a print statement where it prints I and then it counts as the end. And then we have a statement with a plus equals. So all this means is that I will equal itself plus whatever value is there. So in this case, we have 1. So after the first loop, I will equal 1. After the second loop, I will equal 2. And if this pattern keeps continuing and this code continuously runs, eventually I will be greater than 10. And then this loop will cease to function and it'll just completely stop. And that's the difference between while loops. So while loops isn't going over a set or a certain range or a certain set of data. It just continuously goes until it realizes that the condition has been broken. One method that people use is they do a while and the condition is true. So the condition is just by default always true, and that loop never breaks. So that's if you want something that's just continuous. Depending on your software, sometimes you need that if you just want it to run as long as the program runs, you'll have that continuous loop. So now we're going to jump into Boolean statements or Booleans and conditional statements. So a Boolean is basically a binary value. So by binary, I mean 0 or 1, and we treat them as trues and falses. So a value is either true or a value is false when it's a Boolean. And these point into what are called conditional statements. So similar to the condition that we talked about in the while loop, conditional statements are basically that first if statement we saw in that first example. So these statements are basically explaining if X is true, then proceed. If not, skip that line. So there's 3 different types of actual conditional statements that we can look at. There is the if statement, there is the elif, or more commonly known in other language, else if, and then there's else. So these 3 conditionals are actually just in terms of priority. So if you enter a chunk of code and you have an if statement, and then you have an else statement, the way it would function is that it would find the if statement, which needs to be before the else if statement. This if statement, the conditional will run if the conditional is found to be true. Then it'll run the code, and then it will skip the else if. The else if is only if the first statement is not met. Then you enter the else if. So in the case that you want 2 conditionals to run, you'll have them both be ifs. In the case that you want only one to run, you'll have one be an if, one be an elif. And then you can look at the difference in the conditionals and see which ones are met, if any. And then you have the final case of conditionals, which is an else. Else is a catch-all case. So the way else works is that if all preceding if and else elif statements fail, then the else condition runs. And the else condition basically doesn't take a conditional into play. It's purely based off the default, right? So if nothing else matches any of the conditional statements, we dive into our else category and we run that. So in this case, if x does not equal 0, and if x is not greater than or equal to 5, then we'll run running out of chocolate. So now we'll go over the actual conditional operators. So just some of the common operators that you might look at are a little different than what you might consider like general mathematical operators. So you might have noticed that all of the equals conditions that we've looked at use a double equal sign. So if you are checking the condition that 2 values are equal to each other, you would use this double equal sign. This is because the single equal sign is the meaning of the single equal sign is that it is assigning a value. So if we look at one of the previous examples here, when I equals 0, what we're saying here is that 0 is assigned to the value I, and that's different than actually comparing them. We're not looking to see if I is equal to 0. We're setting I to 0. So when you're actually comparing them, you'll use a double equal sign. And this won't change the value of x in this case. It won't change the value of that variable. It'll just check to see if the two values are comparable and then the same. Then we have the not equals, which is obviously the opposite. It'll be a true value if the two values on either end are not equal to each other. This is defined by an exclamation mark followed by an equal sign. So in this case, if the first if statement here was an exclamation equals rather than equal equals, we would be able to see that only on cases that x is not 0 will the following code pass, and on the cases where x is 0, it'll skip that statement. And then we have our greater or less than operator, which is self-explanatory. Put the greater value. If the greater value is on the large side, passes as true. If the greater value is on the mouth of the alligator or the head of the alligator, then you know that it's false and it won't run through. And then similar to the not equals, we have if you had an equal sign to the greater than or less than symbols, you get the option of a greater than or equal to. So in this case, you have x greater than or equal to 5. So in this case, if x is equal to 5, it passes as true. If there was only a greater than sign, if x was equal to 5, it would pass as false because it would be equal and not greater. So that condition would not pass in that case. So now we're going to jump into functions. So if you looked at this previous example, you could see that we had this 2 lines of code at the top and bottom that were tabbed differently. One that's a define line and then one that's a calling line. So we'll get into that. So basically what a function is in Python as well as other languages, it's a way to run a chunk of code multiple times without actually having to write that code out multiple times. So in this case, we have a function shopping. Basically, what a function does is that it'll take in certain data and then it'll return a different set of data. So a simple function, for example, displayed here is a shopping function, and what this would do is just return the number of bars that you own. So in this case, we're going to take an input. All the inputs are defined in the brackets of this definition statement. So def shopping will define shopping, and then we'll define the inputs in the brackets. So the variable shop will be an input. The variable bars owned and the variables bars by will be an input. And then these inputs are going to be based off of A, either whether the user actually puts in these inputs, or B, whatever we set as these default values. So here we're setting shop to equal Y by default. We're setting bars owned to equal 0 by default, and we're going to set bars by to equal 3 by default. So if no one enters anything different, these are the values that'll be going forward with this actual function. Now, anything tabbed one space in to the function is going to be within that function. So the first thing we interact with is a conditional statement, like we touched on. In this case, we're going to go over whether the shop value equals Y. So let's assume that it's default to start, right? The default conditions, shop is equal to Y. Now everything that's tabbed in, we can now go into and follow that as if it is actually running because the condition passed. So print going to the store, and then it would make bars owned equal bars owned plus the bars by. So it's just adding the bars by value to the bars owned value. And then the return statement is basically what you'll get when you use the function. So any of these 2 lines at the bottom are both 2 types of calls. Basically what that means is that when you actually want to use the function after you've created it, you just call the function name and then put in your parameters. And that'll basically equal whatever the return value ends up being. So these 2 call functions will return the exact same thing because the first one puts in the parameters y, 0, and 3, and the second one puts in no parameters. So that means when it goes to the default parameters are again y, 0, and 3 for those 3. So both of those will actually return the same thing always. But let's say you swapped out y for n, then it just wouldn't run. It would return the bars owned. If you swapped out 3 for 4, it would add 4 bars, and you could change these parameters depending on what you needed to do, or you could keep them the default if you needed. Okay, Now we're going to jump into the concept of classes. So Python, as well as other languages, have classes, and classes are a method that lets you basically create new sorts of types of items, right? So different classes. So for example, yes, I could create a variable that holds a number. And like I said, in Python, you don't need to define what the variable is holding. It'll figure it out. I could have one that holds a string, which again, piece of text. I could have one that holds a character, so a single value character. Or I could create a class. And in that class, I can have a variable that holds a piece of chocolate, which, you know, just saying that doesn't exactly make sense right away. But if you create a class for it, basically that chocolate that you're putting in the variable holds its own values. So in this case, we are going to create a class chocolate, and that's from that first line there, where it's just the class keyword followed by the name of the class that you actually want it to be. And then, like before, anything tabbed in is considered within that. So here we have a function similar to what we saw, but this function has a very unique name. So the double underscore in it, double underscore, is basically means it's initializing. So if you guys are familiar with other languages, like Java, this is basically what we consider a constructor. So just to slow things down a little bit for people, all this is doing is defining what values are inside of our class. So when we look at a piece of chocolate, we're going to be able to know the flavor. So self.flavor means the flavor of this specific class, the flavor of myself inside, because inside the class, so the class is referring to itself, and then it's defining the variable flavor. So the flavor of that specific instance of this class. So by default, it's blank. And then if we take a line down, you see how we're all the way tabbed out. So we're no longer in the class. We're actually just running our code. So here we're setting a variable chocolate1, and we're making that equal the class chocolate. It's kind of defined similarly to how the function with the default parameter here was defined, where you have shopping with empty brackets because it's seen as a default parameter. It's defined similarly, but basically what this does is as soon as you look into this class and this class gets used, it'll jump to its initialization function, which is the init function you see there, and it'll define a sub value for itself. So by default, like we saw, the sub value is just a blank piece of text. And then we can set flavored equal to orange. So now we have one variable containing a piece of chocolate, which is our class. We have one variable containing a flavor. In this case, the flavor is orange. I don't know how you guys feel about orange chocolate. I have other types that I'd prefer, but in this case, the flavor is orange. And then if we want to set the flavor of that actual piece of chocolate and that chocolate variable to orange, we can use chocolate1, which is the piece of chocolate, dot flavor to access the property of that class. So if this chocolate object, we have flavor, and we're setting that flavor to our flavor variable. So the flavor variable holds orange. So now the chocolate's actual flavor we're setting to orange. So now we can run through a print statement. Print statement, like I said, very simple built-in function in Python. So we're just combining all these pieces of text with that chocolate.flavor. So we end up getting the you have portion of the text. Then we add whatever chocolate.oneFlavor is, and as we previously mentioned, it's a piece of text. Piece of text is now set to orange, so you have orange, and then finally a piece of text that says flavored chocolate. So this is just a way of accessing, like a very simple example of how to access classes and use them to create new types of variables that you can hold more complex information in. So we'll jump to another slide on classes. Basically, now we're going to talk about what are instance methods. So like we talked about before, we are defining our class of chocolate up here. In this sort of chocolate class, we have the keyword again, chocolate. It's the same thing, same type of object. Now we are going to define it a little differently. As you can see, our initialization function here is somewhat different than our initialization function up here. So we have the initialization function with an additional parameter. So self is always one of the parameters. All that means is that we're defining information, the class is defining information about itself. Then we have a new parameter. In this case, it's number. So similar to all the other functions we looked at, you can have parameters and you can have a default value for that parameter. In this case, we're defaulting the value to 3, but if someone inputted something different, it would get that different value for number. So this is just a way to represent that 3 is the number of chocolates that you have. So again, we're going to use self.flavor. Self.flavor is going to be our flavor value, and then self.number will be our number value. So by default, we're going to set flavor just to a blank piece of text, and we're going to set number to whatever the input number is. So now we can use these as standard variables. So we can make a chocolate variable again. If we do chocolate.number, we'll get whatever number of chocolates are. We can edit chocolate.number. We can edit chocolate.flavor. And we can have these properties of a variable change rather than the whole variable changing. That's the benefit of classes. And then what we can do is, as you can see, this next function right here, define print number, is actually within the class. It's tabbed in, so you can consider that part of the class, and it also takes the parameter self. So what this means is that it's running on itself again. Basically, what's the difference between a function like this versus some of the functions we looked at before is this is an instance method, meaning that it only works on an instance of the class chocolate. Because if you don't have a variable holding a chocolate, this function doesn't run off of it. You need to run it off of something within this class. So the example would be if I ran this off the chocolate variable we created here, and let's assume by default it had 3 pieces of chocolate in it, it would print there are self.numbers, whatever the value of that chocolate self is. So in this case, number is 3 by default, comma self.flavor, whatever the value of that chocolate self's flavor is, and then chocolates left. So if the flavor was set to orange and the number was set to 3, this print statement would then return to us that there are 3 orange chocolates left. And that's just a way to have a function that's specifically made to work off of an object in one of your classes. So now we're going to run into some actual code examples. So I'm going to pull up a Google Colab notebook, which will probably be a standard that you guys will see. Basically, for all the following workshops, we're going to have a workshop followed by a notebook that we can run through and actually go through the code. And this is mainly because slides can only offer so much information, and actually being able to see code run is a big benefit, especially for the competition once we get into some of the more important workshops when it comes to the nitty-gritty part of machine learning and data science. It's going to be very important to see how the actual code runs rather than just an overview on slides. So we're going to jump over to that now. Okay, so this is kind of like the environment we saw earlier, except that was just a demo of Colab. Now we have an example of something that you can actually use these notebooks for, and that is storing actual code that you've written and being able to present it in a more organized way. So we start off here with our first text box. So it's a text cell, kind of like how we talked about in the previous presentation. So again, this is just going over the overview of the concepts that we're going to look at. These are the similar code snippets from what we used in the actual slides. So we can actually run through them and actually interact with them this time. So quick review, again, syntax and variables we'll run through again. Then we'll run through functions again. We'll go through our conditionals once more, our loops, and finally our classes. So this is the same code that you have. And as you can see, we can actually look at the outputs that have been saved from previous attempts, which is a really nice addition that notebooks have that scripts do not. So like I said, great for prototyping. So yeah, we'll run through the quick review in 1 second. Okay, so here again, we set chocolates to 0. Then we should be able to print the number of chocolates we have, which by default, again, we just set it to 0, should be 0. Should get the options, put in input, and then if that conditional is met, we will get that input. So let's try this piece of code out and see how it works. So here we're actually just connecting to a runtime right now because it just needs to give us access to that first cell. Just takes a while to run, but here we'll go through it. So like I said, chocolates were set to 0. So our first print statement here lets us know that we have 0 chocolate bars. Now it's asking us if we want to go to the store. I'm going to enter y as my response, which is this input variable. You can see this little green arrow follow what line of code we're on. And then I'll click enter. It'll input that. It just ran through all the rest of the code. So we get the going to the store print line, which is in the conditional as it's tabbed in. And then we get the addition of our chocolates. So our chocolates were 0. Now we add 3 chocolates, and we print that out down here. So that's how the conditional would run if you entered a y. But now let's see what happens if I enter an n. I get 0 chocolate bars, and that's because the code right here, everything tabbed inside, just won't run, and that's because the conditional is not met because store does not equal y. Store equals no in this case. So that's just a very basic example. As you see, like I said before, the variables don't need types. They're automatically defined with that. Our conditionals and everything ran perfectly here. So now we can jump into an example of a function. So here we're going to have a function. We're going to define the function again, shopping. It's the same function we talked about. We have the same default parameters that we used to have. So we have the shop parameter defaulted to y. We have our bars defaulted to 0, and we have our bars that we're going to buy defaulted to 3. We have the same conditional, which in this case is the if shop equals y, followed by going to the store, buying your bars, adding your bars, returning your bars, and then we have again. This is just a different way of doing the same thing we did before. Chocolate is 0. We're going to print that. We're going to take an input, and in this case, we're just going to set our chocolate to whatever the function returns, and then we're going to print that out. So let's run this. Okay. So you see how we're getting the input here. So now we're at the input line again. If I enter y, it'll jump to the chocolate line, and the chocolate line points it to the shopping function. So now we're going to be in the shopping function. Our store is going to be equal to our shop. Our store was our input. I put in y. So our shop value is y. Chocolates was defaulted to 0, as well as we inputted chocolates. So that value is 0. And then for bars to buy, we put in 3. So all those are in. Those are our parameters for the function. Now we're just going to run through code that's in the function. So everything that's tabbed in is in the function. So first we'll hit our conditional statement here, which is if shop equals y. In this case, it did. Then we're going to jump down to our print statement, going to the store, and we're going to sum our values, and then finally return that sum. So the return value is what comes out at the end of this function call. So this will end up equaling whatever the return value is. Now running through here, it'll basically tell you 3 chocolate bars. If we change this value to 9 chocolate bars, and we change the initial value to 10 chocolate bars, and we run it, it'll say by default we have 10 chocolate bars. We want to run it, now we have 19. So basically, this function just adds them and adds a couple print lines to it. If I say no in this case, not only will it skip the going to the store print line, but again, it doesn't add anything. So now we can go into our conditionals again. So same conditional we talked before. Like I said, the double equals is making sure 2 things are equivalent. The greater than or equal sign means that x is either greater than or equal to 5. So if we go through the definition of enough chocolate, we can see that when we run this function, we want x equal to 0 here. If in that case we have no chocolate left, so we'll make this print statement. If x is greater than or equal to 5, that means, wow, we have a lot of chocolate. We have over 5 or more pieces of chocolate. And then any other condition, we're running out of chocolate. So assuming the case that we can't have negative pieces of chocolate, we can assume that any condition that is not greater than or equal to 5 or equal to 0 is less than 5. So we can assume, it's running out of chocolate. So look at the old output, it was running out of chocolate, because if you remember, we defaulted with 0 chocolate, and then the function added 3. But I just edited it to have 10. So what we should get out of here is there's so much chocolate, because we have so much additional chocolate. So in that case, as you saw, we hit this first conditional statement, which was x equals to 0. We had 10 bars of chocolate. So we skipped this one completely because we don't match the condition. We jump down. In this case, x is equivalent to the bars of chocolate we have. So is 10 greater than or equal to 5? Yeah, it is. So we run this print statement. We don't worry about the else statement because one of these conditions have already been met. So now we're going to run through the loops again and actually be able to see the code. So like I said, for each item in Choco list, we print that item. So if we add another item in the case, I don't know, what's another chocolate flavor? Bad, like maybe there's a bad flavor of chocolate, I don't know. But the original output stopped at orange. If we run this, we also get that additional bad. So it'll just iterate for every item in that list. If you wanted to, you could also do something like this. You can use a function range. Oops. And then within that, you can do a range of the length of this. So basically, length will just give you the length of the list, and then range will iterate through those numbers. So in this case, we get 0, 1, 2, 3, 4, 5. And it's just iterating through this. So we get 0, 1, 2, 3, 4, and 5. So these are just different ways you can iterate through lists and iterate through the ranges of numbers. So that's just a useful tool. And then the while loop, it's the same situation we talked about before, where it'll continuously run until that condition is broken, this I less than 10. So if we run it, it'll keep incrementing the value. And as soon as it gets greater than 10, it just cuts it off there. It doesn't bother running it with that value. It just stops right there as soon as I is no longer less than 10. So once I hit 10, it was no longer less than 10, and the loop got cut off right there. Okay, and then we're going to run to our classes. This is probably the most complex part that we talked about in this Python intro. Again, for those of you who are well versed, this might be a little slow, but it's a good starting point for anyone who isn't too comfortable with Python. So the class lets us create a value of the type chocolate. So like before, we're defining a flavor, we're defining a number of chocolates, and then we have an actual function that only applies to chocolates because it's in this class. So chocolate, we create chocolate, create a flavor, put those flavors together, have a print statement, just like we talked about in the slides. Then we have creating a second instance of a chocolate class with different attributes and values. So this is a chocolate 2. So we're going to create a chocolate, and we're going to put number 5. So we're going to basically change the parameter here to 5, set the flavor to mint, and then say I have, mint flavored chocolate. And then we can use the function print number here. So we have orange flavored chocolate, then we have mint flavored chocolate, then there's 5 mint chocolates left. So as you can see, the way we called the function here is a little different. We actually had to put it after the variable, so chocolate2.printNumber, rather than putting the chocolate2 as a parameter in the brackets. This is because the function is running off of that class rather than that class just being used as a parameter in the function. So here again, we had our flavor chocolates, and then here we can define the definition of print number is there are self numbers. So our self number was 5, our self flavor was mint, and then chocolates left. So that's the end of this notebook, but basically that's how a lot of concepts in Python work, as well as a great intro to using the notebooks first and foremost, because these notebooks provide a lot of value. So in this case, we only did some Python fundamentals. We didn't actually do any manipulation with any files or data that we have, but the tabs here on Collab allow for that. So I can connect my drive here. I can go through code snippets here, and then I can, find and replace here. Access to my drive. I can create a new notebook, save this in drive, everything like that. It's great. And then the one other thing that's important to show is the runtime option. So basically, I can change my type, and like I said, I can use a GPU that they'll give to your virtual machine for you. This is very basic Python code, so we don't really need a GPU here, but more advanced machine learning tactics usually do. And then there's obviously the run all function, so it'll just run everything for us. Just go through these. And everything ran through. Yeah, so we finished a little bit early, so we're gonna open the floor for any questions, either in the Discord chat or just through Zoom. There were a couple things asked in the Zoom chat while I was presenting, so we'll just go over those. Yeah, so some people asked about getting the actual slides. So you referred to for the coding presentation for this afternoon. Yeah, I think that we can definitely get the slides to you probably a little bit after we shoot off the competition, give you guys the information for that. Yeah, you guys might want to refer back and forth between them, so it's probably a good idea. I'm assuming, John, you're good with that. Well, we're good with sharing slides. Yeah. All right. Perfect. So, anyone have any other questions just on Python, collab, or any of the content we covered so far? Just out of curiosity, I know we covered this as a Python for a beginner segment, but if you guys want to or willing to share in the Discord chat, just like what is your level of Python? How comfortable do you guys generally feel with working in this environment? Oh, we got some people typing, so we'll give them a second. Took 1026, pretty much it. Yeah, that's fair. A lot of people, have a background that's not very Python related. A lot of software development happens outside of Python. Makes sense, but if you do have just a general understanding of any other programming language, Python's like super easy to adapt to. Jumping to Python is a lot easier than jumping from Python, I would say, but it's a great starting point. So what did some other people say? Mostly good. Got to review classes again. Yeah, that's fair. Classes always get you. I've done everything up to, but not including classes. Okay, this is interesting. Seems like some people have familiarity up until the classes portion of it. So classes are interesting because in our machine learning demos that we'll be doing later today, classes do play a role. A lot of them are built-in classes, thankfully, so you won't be too concerned with creating them from scratch. They'll be coming from libraries that we'll be importing. So it's good that you guys are getting like a little intro to classes and understanding that you can sort of run your functions for that specific class rather than like a standard function. Might make it a little bit more clear when we jump into some of these libraries. What else? Did you worked for 3 years, used Flask? Oh yeah, Flask is fantastic. If you guys aren't aware, Flask is a way to, it's an add-on to Python that lets you basically run a server. It's great for creating like a website backend through Flask. It's just another cool use of Python, and actually how a lot of our Western AI project groups end up deploying their projects is through Flask. So if anyone's interested in project groups, we definitely will be talking about that in the future sometime. Same here, 1026, 1026 gang. Okay, that's fantastic. New to collab, but I've worked with Python on and off for a couple of years. Makes sense. Yeah, if your collab is very easy to pick up, especially if Python's not the concern for you. It's once you get into the notebook sort of style of things, it's really nice, especially when you're just planning out your software. A lot of people took 1026. Is 1026 an exclusively Python course? Like, is it like an intro to Python course? Anyone know? Yeah. Okay, that's great. I don't know how far they covered, but it looks like they didn't cover all the way to classes. Okay, all right, 2220. So basics are there. That's good to hear. Oh, they did cover classes. Okay, cool. So that's great. So I think if no one really has any questions in addition to that, John, we get to jump into libraries a little early, maybe give them a little bit of leeway before they jump into Project Manager Lunch and Learn.
We could do that, or we could take a 10-minute pause here and return at 10:30. Maybe if everyone wants to continue, click off the speed up icon. If you want to take a 10-minute break, click the slow down icon, just so we can get a feel for what you guys want to do. Okay, I'm seeing a lot of
slowdowns. Yeah, that's true.
Let's break for like
all right, sounds
11
good.
minutes. We can return at like 10:30 if that works with everyone.
All right. Yeah. After the break, we'll be going over Python libraries. The libraries really important concept, especially doing machine learning in Python. So make sure you show up for that. Come back for that.
This is the stuff they don't teach you in class.
Yeah.
Okay, see everyone in 10 minutes.